Welcome to In the Lab at Tench Labs, a chance for you to see the development of a new product, a new invention, exactly as it's happening. So you're going to see the good parts, you'll see the disappointing parts probably. We're going to build something really exciting here. Who are we? We're Tench Labs. I'm R.A. Tench. We have a new mechanical process that has a lot of great advantages over existing mechanical processes. And we're applying it now to something that might seem a little dull, which is a humidifier that works in a refrigerator. But really, it's really exciting because you see, all of the legacy humidifiers, they can't work in refrigerators. They make droplets like that mist that you'll see in a baby's room. A baby has a cough, you put in one of these humidifiers that makes a mist. So that mist evaporates relatively fastly in a baby's room because it's a high temperature, relatively speaking. And even though there will be some water around it, it's not terrible. But when it goes into a refrigerator, where the temperature is 3-4 degrees Celsius, a few degrees above freezing, then the rate of evaporation goes way down. It drops by 50 or 100. And all those drops don't evaporate. Long before they evaporate, they touch each other, touch surfaces, collect together. They get an evaporation time of many, many hours. More come in, and they just create puddles that are a petri dish, and they grow all kinds of pathogens, listeria, bacteria. So because of that, they've never used it. Probably you might have wondered, like, why isn't there just a humidifier dial in my refrigerator? Why can't I just like set the humidity that I want? I can set the temperature, should be able to set the humidity. And they have all kinds of talk about what they offer you in the refrigerator. But those little boxes that are the crisper boxes, they're a death sentence to vegetables. Let me explain how this works. We're going to just take a quick look at one here online. Now, this happens to be a particularly bad one. Here's the Fresh Keeper. It's not at all Fresh Keeper. These vegetables, like those greens there, the cucumbers and lettuce or parsley for sure, things like that, they have to have 95 to 98% humidity in order not to die. Vegetables are alive when you pick them, and they can stay alive for weeks and months. So if they don't have that 98% humidity pushing back on them, they're going to exhale out all of their humidity and wilt. And that's what happens in this, because the humidity here, this probably 40 or 50% humidity. If it's all closed and they have a little sliding tab, you can get it up to 60, 70% humidity just from the exhalation of the vegetables that are in there. But you can't get it up a lot higher than that. And if you do, there are other problems with it also. The second problem that happens here is that if there's fruits in here, like pears or apples, they exhale ethylene, and ethylene accentuates the speed of rotting of vegetables. So it makes it even worse for these things here. Now, up above, you see some strawberries. They're also locked in a little container. And quite often, these things will sweat in a refrigerator, create water, and it grows pathogens, and you get all kinds of problems. So this is our workshop right here. We're going to create, for this refrigerator, a sealed box that'll have a humidity of 95 to 98% humidity, and it's going to keep lettuce and other fresh greens unwrapped, fresh for weeks. Okay, so how are we going to do that? Let's just take a look here, get back to my screen. Okay, we have here our machine, which there are some confidential parts of these videos that I'm just not going to show you because they're machines that we have made and haven't applied for patents for yet. And so because of that, we can't publicize them. But take my word for it, we have this machine over here underneath my hand and a little box like this size. And we're going to attach it with this tube to a plastic box that our partner is acquiring right now and put it into a refrigerator and have it all connected to our humidifier. And then you'll see what happens to lettuce that we put into that plastic box. Just to show you the performance of our humidifier, here is the readout of humidity. And this is a humidity sensor here. And I'm going to turn this on and run our humidifier here. Makes a little bit noise. It's an early prototype. And put the sensor in it, and you'll see the humidity goes up pretty fast. Then I'll take it out and show you the end of the sensor. You can see it isn't wet. Then also it should immediately start to drop in humidity, which means if I wave it like this and if it were wet, then it would have more humidity because the water on it would be evaporating, but instead it's going to causing it get a little bubble of high humidity around it. But you'll see that it goes down. So here we are. I'm just going to turn this on, and you can see. Here we go. The readout. There it is. Put this little wand here, and the humidity starts to go up pretty fast. This is our humidity. You see it goes up at a pretty decent rate. Now it's going to keep going up and up and up. Now I take the wand out, and humidity starts to go right back down. So you can see that it wasn't wet. I'll turn this off now. So we're going to put this together in the next video and show you what it looks like, put it into a refrigerator, and we're going to go on and have our first test with some lettuce and maybe some parsley. And we'd like to invite you to come and to see the next video in this list, and enjoy watching the development of new products. Thanks so much.